Hello and welcome everybody to our first user group event of the year. We have a very special speaker coming to speak to you today. But before that, just wanted to get through a few housekeeping items. My name is Ronald Williams. I'm the Senior Community Programs Manager. Long titles, we love those, here at Cypress. And just wanted to invite you to engage and get closer to the community. I did want to announce that we do have our CypressConf call for papers that have officially launched. If you are a Cypress thought leader, if you are working internally on Cypress projects and you'd love to share those with the world, take a look at the QR code, go ahead and submit an application, and we look forward to receiving that. The second one here, just wanted to invite everyone out to our Cypress Discord. We just passed 13,000 Cypress users as of today. So if you want to be a part of those 13,000 folks talking all things Cypress, feel free to jump into the Discord channel. And then lastly, we're always looking for speaker feedback. So if you would like to be a part of our raffle, which is at the end of the event, feel free to use the QR code below. And now I am proud to introduce Chaturanga, who is going to be sharing today on his presentation. And I'm going to go ahead and let him take it away.
Thanks, Ronald. I hope you guys can hear me. And so, hello, everyone. And welcome to Beyond Bugs, a journey to optimal software quality. I'm absolutely thrilled to have you all here for what promises to be an epic exploration into the world of software quality engineering. Before we go into the good stuff, let me introduce myself. I'm Chaturanga Jayasinghe, and I'm originally from Sri Lanka and now living in Estonia. With nearly 10 years in the software testing trenches, I've seen it all: bugs, fixes, and everything in between and beyond. Currently, I'm working as a senior SDET at Riverty and also an official ambassador of Cypress and a champion at BrowserStack. So quality engineering isn't just my job, it's my passion. So I love to explore new trends in quality engineering and to share my knowledge with the community. So, but enough about me. Today is all about you and the incredible journey that we are about to embark together. So sit back, relax, and get ready to revolutionize your approach to software quality. Let's kick it off. I will share my screen. Okay, I hope my screen is visible to you all. Right. Today, I'm going to speak about 4 areas in the software quality engineering process, but this is important not just to the QAs. As QAs, you can push these things to your team, and this is much more important to the product managers and the product owners as well, because it's about the process that we're going to implement. Among these 4 areas are the shift left testing, the CI/CD process, the proper way, and how you test a release, and also how you do the test designing. Then I will conclude all these 4 areas into one sprint flow and show you how to progress in a proper sprint with all these things implemented. Okay, so the first topic is shift left testing. You might have already heard about it, or maybe you are not heard about it, or maybe you know it and you have not implemented it. But this is a kind of famous concept in quality engineering these days. So we'll have a look at it first. Okay, shift left testing. By the name itself, it says shifting left in testing. So in this approach, what actually happens is the quality engineering activities involved in the earlier stages of the development process. That means actually the testing activities could actually start even before a single code is being commenced. So to implement this shift left testing thing, you need early involvement, and your development process is actually a test-driven development. And you have continuous integration, automation testing, iterative testing, and the collaborative approach. So here I have to emphasize on the collaborative approach, because if you want to give out a software with a better quality, it's not the responsibility of one designation called a quality engineer. It's a collaborative approach. It's a teamwork. Everyone from the product manager to the tester all should work together to achieve this goal. So I will tell you how to implement shift left testing through all these 4 areas and how to implement it in the proper way. So let's see what are the advantages of shift left testing. So through shift left testing, since you move your testing to the early stages, you identify and resolve issues much earlier. And as a result of that, we reduce the likelihood of more complex and costly problems emerging in the process. So, when you have like big issues at the last minute, it costs you a lot. And also it costs you a lot of time as well. You can eliminate this if you move on with shift left testing. And the other thing, like I said, improved collaboration between developers and the testers. You will see why I'm saying this in the next slides. And the other most important thing is faster feedback loops, which is also a core factor in a proper agile process. And this also creates more efficient development processes. So overall, shift left testing is kind of a proactive and a preventative approach to the software development process. So I hope you had an idea about what shift left testing is. Let's move on to the next topic. I know that most of you might already have the CI/CD process in your companies and in your teams, but I have seen a lot of flaws in the way the people are using this pipelines and the CI/CD process. The question here is, like, do you do proper testing in this process? Let's see. Just don't look at this diagram on the screen, but just listen to me first, because I will tell you like what a typical pipeline looks like in most of the cases. So in a typical pipeline, what happens in this process is that a developer will develop the code on their own local dev environment, and then he will push the codes to his branch and will create a PR to merge into the main branch. Right. So in this process, what normally people do is just they run the unit tests and they might be checking the code coverage, and that's all. That's it. But what happens in this case is that you have this possibility to introduce bugs to the main branch, because you're not doing some extensive testing before you merge your pull request. But if you have a look at this diagram here, I have put in the acceptance tests or the functional tests into the pipeline. So what happens here is when you raise a pull request, before it is merged, you make sure that the functional tests are all executed and they are passed 100%. But in this case, you can execute 2 kinds of tests, either a smoke test suite or a regression. Then you might question that, okay, if you run a regression, it will take much time, and the developer will have to wait for a long time to see the results and merge it. Yes, of course. That's why you can go for a smoke test as well. So even if you do a smoke test, what you do is like you make sure that at least the critical scenarios of your application is tested before you merge this new code. And so that makes that that make sure that your application, which was working fine with all features you had, are working fine. So what happens is you block the developers from merging some erroneous codes, at least some erroneous codes which will break the previous features. Sounds good? Okay, right. Then the next thing is that we'll say, I talked about the regression, because sometimes you can run a regression, because we'll say you're doing API development. So API tests won't take much time to execute. So, but also there are exceptions, of course. So if it's possible to run the regression within a short time, just go for it. Okay, then it comes to the deployment. So when you are planning, when you're doing a deployment, actually, you are planning beforehand. Like, we are going to go for a deployment and we will do some testing and all. So save some time to deploy, and you have to test it before you do the deployment. So in the deployment, I would suggest or recommend that you can go for a regression. So you make sure that everything works fine. Okay, when we think about that, someone might question, okay, the developer is putting up a new feature with this new code changes, and that is not automated, so it won't be covered. Yes, of course, that's correct. But then the amount of testing you have to do after this merge is less, because you need to just test the new feature only. The all features are already covered with this testing that happens here, right? Okay. And also, I would say, if you have a proper process and you have implemented in-sprint automation, then of course you will at least have somewhat tested, test cases automated for this new feature that's coming in with these changes as well. I will speak about in-sprint automation and how we can build up a proper process up to this in the future slides. Right, that's about the pipelines. The next big thing here is running these tests and getting the results. Okay. Right. I highly recommend to have a QE dashboard. That's because you need to keep track of the test results, because these results bring you stats, and these stats are the facts, because the facts actually bring in a lot of value to your, not just your quality engineering process, but also for the whole development process. Because we know that there is a saying in software quality engineering that bugs tend to cluster around specific zones and they have a pattern. For example, more bugs are raised along business logic, so where there are critical logics and complex logics are. So if you have a dashboard and if you analyze these things, you know, when you have a look at it, like where these bugs are coming from and how often bugs are coming from these areas. That is why actually I love dashboards. Even on that case, I love the Cypress dashboard. If you have experienced the Cypress Cloud and the Cypress dashboard, I think you know how cool that is. Because in this dashboard, it don't just collect the test results, it analyzes the test results, and it shows different stats like the failure rate, the flaky tests, and how long it took to run the tests, and so on. So from these things, you can come to a conclusion where you need to focus. For example, if bugs are raising up on some specific area more often, then both the developers and the testers can focus on that area. The testers can write more tests to test it properly, that particular area. And also the developers, when they do a change, they can focus more and be precautious. when they're doing some changes. So that's really important to enhance the software quality. I hope you agree with my point. Okay, let's go on. Next is another important area, how you test a release. I know. When you even heard the word release, it's stressful. I know the pain. Okay, so there's a big question here. When you are doing a release, do you do an isolated testing, or we would say a code freeze test? If you're not doing an isolated testing, you might have come across a famous statement. That is, it was working fine in the test environment, but it's not working in the UAT or the live. I think if you are a tester and you've been in this industry, you might have heard this from another tester or maybe from yourself. So, where do you mess? I will explain the typical way and the better way. So, what happens in a typical testing process is that if you have a look at this diagram, the local dev environment, which is the, we'll say the developer's environment, they will build different things. We'll say bug fix 1, bug fix 2, a part of feature B assigned to him and part of feature B and some enhancements. Okay. Then what he does is deploy these things to the dev environment and do the dev testing there. Okay. Right. Then what happens is actually the testers are testing only in the test environment and forward. Okay. So the developer will do his dev testing and deploy it to the test environment. So in the test environment, now we have feature C and part of feature A, some bug fixes, enhancements, and blah, blah, blah. Okay. Then comes a requirement that you need to go for a release with feature C, only feature C. The others are not needed at the moment, but we need to go with feature C. So normally what will happen, which is also not good practice, is that you will cherry pick the code that's related to feature C and create a release package and deploy it to the PT environment or the UAT environment. Okay, now what happens is that when you do the release testing in the PT environment, it's actually not working. And the other thing is, like, for example, in my case, some of the test cases cannot be executed in the PT environment. For example, I need to do time traveling and stuff. Such things are not allowed in PT environment because as a standard, we know that the UAT or the PT is a clone of the live environment. So we don't allow extensive features there because we have our own things developed to test in a better way in the test environment. So those things are not in the PT environment. Right. So what happens is we leak bugs. The reason here is because this feature C was actually working fine along with all the other code changes for the other things as well in the test environment. But when you isolate it and put it into a release package and deploy to PT, it's not working. So what's the better way to do this? To do it the better way, you need to shift left. You have to start your testing earlier. So what should happen is that the developer is developing his own developments on his local environment, and he deploys it to the dev environment, and he does his dev testing there. And the tester should switch to dev environment and do the feature testing here in the dev environment. So when you get the need to deploy or go for a release with only feature C, what you will do is the same thing. You will get a feature C and create a release package, cherry pick it, create a release package, deploy it to test. And then you test it in the test environment where you have all comfortable features and whatever the needs you have, you can do anything in the test environment. So you test it. If you fail there with some bugs, you report it, fix it, and then it's all good. So next, what you're doing is exactly the same release package is being deployed to the PT and live. Exact same thing. No changes. It's the same code that was in the test environment. Not like in before. We deployed a package to the PT environment from the test where like we cherry picked from the test and deployed last time. So ultimately, you have done an isolated testing for your release. So there is no way it can break your quality. Yes. So that's about the isolated testing. I know that you will come across a lot of questions. Just post everything you have in your mind. I will answer as much as possible. Okay, right. I think the next topic is the most important topic, I would say, because everything depends on test designing. So when it comes to test designing, there are multiple ways of doing this. We'll say test matrices, mind maps, and a lot more other ways you can do test designing. But I recommend using mind maps because I feel, according to my experience, that it's way more effective than you might think. And there is an effective way you have to use it. So what's a mind map? Actually, mind maps can do magic and it can be super useful, like I said. So mind map is an easy way to brainstorm your thoughts in a graphical way. Why I say a graphical way is like it's kind of a diagram and it helps you to understand complex things in a simpler way. You know, like we'll say like you have a requirement document in the textual form. When you read it through, it's difficult for you to understand and digest all these things at once when you just read through. But if you put this up into a diagram, it's much easier for you to understand, and also it's easier for you to communicate with others. And it's more digestive than just reading through a text. Okay. When it comes to mind mapping tools, there are a lot of options that you can go for. Xmind, Miro, MindMaster, and there are a lot more. I have experienced Xmind and Miro boards, but I would say the other tools are also really good at this job. Okay, right. So what do you do when you want to create a mind map? You just jot down everything that you come into your mind. You just read through the requirements or the behaviors of, we'll say, a new feature, and you just take up and just jot down everything that comes into your mind, like the scenarios. For example, I have created a mind map here. It's a login feature, and I have divided it into 4 as elements, functional tests, non-functional tests, and UI UX. And then I just write down everything that comes to my mind. And I cross-check with the requirements document whether I have put in everything that was in the document. So this is a mind map. I hope you agree with me that if you look at this diagram, you know what flows that we have in this future. Okay, you can put a comment in the chat or the Q&A, whether you agree or not. Okay, what is the effective usage of mind maps? When it comes to the effective usage of mind maps, I would like to break down this into 5 stages. Before I explain about these 5 stages, I would say how a new feature for an application would come into a sprint in the agile process, in a better agile process. Okay, so we'll say the product owner or the product manager come up with a new feature, and he notes down, we'll say, document it in Confluence. This is the new feature, and these are the behaviors, and blah, blah, blah. And everything is on the Confluence page. So this happens actually way before coming into a sprint, right? Okay. Right. So the stage 1 happens in 2 different ways. So you have the requirement documented, we'll say in the Confluence. And one way is that the PO or the PM will create a mind map with just the happy parts of this new feature. Then the QA comes in and will complete this mind map with the negative scenarios and the edge scenarios. Or else the other way is that just the PO or the PM just document it in the Confluence, and the QA starts from scratch, makes the whole mind map. Okay, that's stage 1. Then when this new feature is coming into a sprint, when it's put into a sprint, what you as a QA should do is that you create a meeting, schedule a meeting with everyone in the team, including the PM, developers, architects, the other testers, and everyone, and showcase your mind map at this meeting and discuss the scenarios you came up with, and you discuss this feature using the mind map at this meeting. So at this point, developments have not started for this feature. Okay, right. Then stage 3 is you will have some outcome from the mind map discussion you had. Then you take the feedback you got and update the mind map according to that feedback. And then when the development starts, you have everything on your hand in the mind map, and you can just simply derive the test cases from the mind map and populate them in your test management tool. We'll say X-ray, test rails, or whatever it is. And stage 5 is at some point you will execute the scenarios you've got. That's it. So what's the big deal? We'll see what the big deal is. I will first speak about the beta sync. So in the above process at stage 2, we gathered everyone and had a discussion, right? To be honest, it's amazing what happens when a group of people get together with the markers and work together on a mind map, and it's fun. And it does the job better than you think, actually. I'm telling with my experience, trust me. So I'll explain what happens in this meeting. So the PO or the PM have documented the feature behaviors in a textual form. And if you don't have a mind map and if we have not done this discussion, when people come in to a discussion, the developer have some kind of an understanding by reading through this document. And the QA is also having another kind of understanding about this feature. But in some situations, actually, what they have understood is not at all the same thing that PM or the PO wanted to express in the text. So that's a mess, I know. By having a mind map and doing a discussion with this, what happens is all these people come into a common understanding. And as a QE, if you have missed any scenario in this mind map, when you discuss this in this room, someone else will point out the missed scenarios. And also, the other point is that sometimes developers have not thought of any scenarios that you have come up with, with the edge cases. So they will get to know that there are flows like this in this feature. So I should focus on those things. So you eliminate some bugs there, actually. And the other thing is when you discuss it here with every team member, you will also get some new ideas to enhance this feature. That's a plus point. Okay, so at the end of this meeting, everyone will have a common understanding on the same grounds. So it will have a lot of advantages. Just believe me. Next, I will speak about saving time. So what happens when a bug is found? You raise the bug, notify the developer, and then at that time, developer might be on a different mindset and focused on something else. So the developer have to jump back to his old code, focus on it and work on it. And if it's again given in any bugs, the cycle goes. What a waste of time. But if you invest a little time in mind mapping, you can eliminate this because the developers, QEs, everyone are on the same understanding. They have the same understanding about the feature. They know what to do. They know what to expect when you develop this. So you save a lot of time by eliminating bugs in the development itself. Okay, lesser bugs, time saved, and it's not the most important thing here. The most important thing is test scope scaling because everything depends on this factor. If you miss any important scenario in your test phase in a critical software, it can be a massacre. I would like to take one example for this. On 10th March 2019, an Ethiopian Airlines flight 302 crashed and killed all 157 people on board. Do you know the reason? The reason was the Boeing 737 MAX jet had a software glitch. That's how dangerous it is. So software quality is really important and test designing is really important because in test scope scaling, you need to be very precautious. Mind mapping will save a lot of issues in this process. Give it a try and let me know what you think. Just ping me somewhere, LinkedIn, Facebook, anywhere. I'm pretty sure you'll be impressed with this process. Okay. Time is flying, and we are also getting closer to the end. Right. Now let's try how we progress in an ideal sprint. Okay. I've talked about this in mind mapping. So before sprint start, what we normally should do is we discuss the upcoming sprint items, and discuss sprint developments, and also discuss any possible blockers or risks in the development that we are going to do in the next sprint, and create mind maps for the testable scenarios. So this happens before a sprint starts. Okay. So for this to happen, you should follow the proper agile processes. So if you have a proper agile process, you have a backlog of tasks and you have prioritized your tasks, so you know which items are coming up for the next sprint. Okay. Then, first week of the sprint. Like we discussed, when you start a sprint, you straight away go for this mind map discussion, or else we could also say three amigos meeting. And you have to make sure as a quality engineer to do these things. Discuss the mind map in the meeting, update the test designs based on the feedback, and then derive the test cases from the test designs. And I highly encourage you to do in-sprint automation. In-sprint automation means if you are bringing in a new feature in this sprint, you try to automate the tests of that new feature in the current sprint itself. It could be possible, could not be possible. That's depending on the situation and the context. But I would say try your best to do this. Second week of the sprint is totally up to you, the quality engineers. It's totally about testing. The development phase will be over, or mostly the things will come into your testing phase, and you will do the testing and follow your usual work as you do. And the important thing is that you will come across less issues since you are already testing the new codes in the pipeline and you did mind mapping. So it will make a result of less bugs when you are testing. So you have much more free time to do more testing, like think out of the box. You can do some exploratory testing and do whatever, like do crazy stuff. You can, you know how to test. I don't want to tell you. You can do different types of testing. So you have time for that because pretty much everything is automated and you have done a good job in the earlier stages. Last but not least, the sprint closure. Give the final touch. It could be possible or could not be possible to test in live environment because some don't, some do. At least try to do a smoke test to make sure your critical scenarios are passing in the UAT or the live environments. That's it. So, in conclusion, like I said, it's a collaborative approach to achieve this goal of optimal software quality. It's not just a responsibility of a single person or a tester. So it's a collaborative approach. It's a teamwork. And what I've seen is that blame is being placed on the quality engineers for low software quality, but it's crucial to recognize that deficiencies often stem from the flawed development processes. So refine your development process and it will lead you for a better software quality. So that's about it. And we can now go for the questions, actually. I hope you have questions. I will try to answer as much as possible. And if I could not answer all your questions, then of course you can reach out to me and I will answer you for sure. Okay, I'm looking at the Q&As. We'll see. We'll take the first question. Can you explain more about release packages, as we don't follow any like in our platform team? Thanks. Okay. Yeah. So normally what happens is it's more relevant to the developers, actually. What developers do that when you want to do a release, and if you just want to only, there are a lot of PRs being merged to the main. And if you want to specifically go with one feature, you have to pick the code changes from the PRs that are related just to a specific feature development. So what the developer will do is they will just cherry pick the code and create a release package. So this release package includes the previous code you had in the main plus the new code changes for this new feature, and it is that package being deployed to the environment, to the next environment. So I hope you got the idea. Right, I will go to the next question. What is a good level of the mind map? How big and small should you define the breakdowns? That's actually a good question, because mind mapping does not have, a baseline, like it should be like this. You can break down it into different ways. For example, in my case, it's kind of a complex solution. So if I draw a mind map, a single mind map, it will be a really big tree with lots of branches. So what you can do is you can break it down. Like if you have a really complex one, you can just take just one component and draw a mind map for that particular component only, and take another component. If there is a link, you can link them. Like you can have multiple mind maps. For example, in the Miro board, we can create multiple mind maps, and you can just put some link between them. So it won't be much complex. So you take down one component at a time with the mind maps. I hope you got your question, your answer, sorry. Okay. The next question. Is it advisable to conduct test scripts with live code, or is it preferable to keep test scripts separate from live code? If yes, what type of test levels are recommended for this approach? Okay, that's a pretty hard question. Yes, it's a good question, because I would recommend having the test scripts in the same solution as the application code. That is because you will come across this kind of a situation. We will say that a developer is trying to merge a PR and he's failing because the acceptance tests or the functional tests are failing. Then you have a problem, because he's not able to merge it because it's constantly failing. Then this depends on the context or the situation you are in. If your test automation framework is mature enough, or if it is really matured, even a developer can fix a small test script. We'll say like the developer have changed some element, so the element locator have changed. If your test automation framework is mature enough, you will have to update the locator of that element just in one place. I mean, if your test framework has a separate object repository and you have like modularized everything, then you don't need to update multiple places for a single element change. So it's preferable to have the test scripts also in the application solution, because then it's more accessible for the developers as well. They can just simply fix it. And if the case is that with the new feature, your previous features are broken, of course, the test will fail, and then it could be a bug. You have to fix it. Or else, if it's a complex thing to fix, then of course, the tester will have to kick in and check what should be done. Okay, I hope you got the answer. We have one more question. What if you don't work with sprints at all? Just a continuous development flow, one feature after another with rapid releases. What would the QA flow be like? You talked about the sprints here. Okay, that's a good question. Because, okay, how can I say this? So far in my career, I've never been in this situation of not having sprints, actually. But you can apply some of this. But like I said, if you're doing a development process and if you have a proper plan, of course you can apply this. But if you don't have a proper planning in the development process, it's a bit, hard to optimize the testing process as well. Because like you said, you don't have sprints, but still you don't have sprints. It's okay. So, but still you will plan for a deployment, right? And the other thing is like you say that there's a rapid releases. If you want to have a rapid release process, you should have a better testing process as well, or else you will be just releasing features one by one after another, but you might not be testing, and it could generate a mess actually. So in that case, somewhere you have to plug in testing. To plug in testing in a proper way, I would say start from where you bring something new into your application. Start from there, start mind mapping and apply it, do the development, and then you have the testing. And if you set up this pipeline properly, yes, of course. And if you do in sprint automation, I would say like not in sprint, because there are no sprints. At least when a development of a particular feature is happening, you do the testing as well along with it. You do the automation testing development along with it. Then, of course, you can just deploy it because it will be tested in the pipeline. You don't have to mingle in the middle. Yeah. I hope you got the answer. Thank you very much for the questions. Okay, right, I think that's about it. And as we wrap our session today, I just want you to give a huge shout out to all of you for being a part of this incredible ride. I hope you learned something, and we definitely challenged some old school ideas about software quality. And remember, this isn't just the end of the road. It's just a pit stop on our ongoing journey to software quality excellence. So let's take what we've learned, keep those conversations going, and continue pushing the boundaries of what's possible. If you have any further questions, and feel free to reach out to me on LinkedIn or, of course, Discord or Facebook Cypress group or wherever. I am happy to help you whenever I can. And I hope to see you guys on another day, on another session, probably. And thank you very much for joining.